last time we were in section 2. And we had talked about our definitions of sine, cosine, and tangent. We talked about how to determine which side was opposite and adjacent and hypotenuse in a right triangle. And we rehashed the SOHCAHTOA acronym that we had used during geometry to define our ratios for sine, for cosine, and for tangent. And then we had also introduced 3 other trig functions. So we had introduced cosecant, which is the reciprocal of sine. We had introduced secant, which is the reciprocal of secant. It's the reciprocal of cosine. And then cotangent, that's the reciprocal of tangent. So what we're going to do now is we're going to do some examples of applying this information and doing some example problems of the sorts of things you'll have to do in the homework. So let's say that we're given this triangle and we're asked to find the exact values for all 6 of these trig functions. So I want sine theta, cosine theta, tangent theta, cosecant theta, actually probably should write it this way, secant theta, and then cotangent theta. Okay. So if I look at the triangle that's given to me, do I have all the information I need to write down these 6 ratios? No. What do I need additional piece of information do I need? I need the hypotenuse for this triangle. How would I find that hypotenuse? The Pythagorean Theorem. So a squared plus b squared equals c squared. What do I have to remember about filling in the numbers to this formula? The hypotenuse is always c. The hypotenuse is the side we're actually looking for in this case. So in this case, I get that the hypotenuse is the square root of 29. Now notice that the directions ask me to give the exact values. Since the direction is asking for the exact value, I'm going to leave that as the square root of 29 rather than converting it to a decimal. Everybody feel okay to hear? Okay. So now I'm ready to start filling out my values for these ratios. So what is the ratio for sine? Opposite over hypotenuse. So relative to the theta we're given here, which side is the opposite? 5. And the hypotenuse we just had found is 20, or square root of 29. Everybody feel okay here? Now, this is not the way that we're going to leave our final answer for this problem. If you remember from your algebra course last year, we didn't like to leave square roots in the denominator of our fraction. So that policy is going to still apply here. Does anybody remember what we need to do to something like 5 over the square root of 29 to get rid of the square root in the denominator? So the process was called rationalizing the denominator. And what we'll do is we'll multiply the top and bottom of this fraction by the conjugate of the denominator. Now, in this case where the denominator is a single radical, the conjugate of the square root of 29 is just the square root of 29. And I know the square root of 29 times the square root of 29 is just regular 29. Okay. For cosine, let's do that one next. What's the ratio for cosine? Adjacent over hypotenuse. In our case, what side is the adjacent side? 2. So I have 2 over the square root of 29. And just like in the previous one, we don't want to leave that square root of 29 in the denominator. So we're going to rationalize the denominator and say our final answer is 2 square root of 29 all over 29. Tangent. What is the ratio for tangent? Opposite over adjacent. So in our case, the opposite side we said was 5, and the adjacent side we said was 2. If you wanted to, you could write that as 2.5 since it's an exact decimal, but I would just leave it as the fraction 5 over 2. There's no harm in doing that. Because it's a terminating decimal, because it doesn't go on forever, it's not incorrect to do that. Okay. If it was 1/3 and you wrote 0.3, that would be incorrect because it's asking for an exact value. Okay. So if you have to do any rounding, it's no longer an exact value. But 2.5 you don't need to round because it terminates. But can you repeat that question? Correct. Yeah, and it's really only because we have the convention that we don't leave a square root in the denominator. So that's the only reason I'm doing that step in green there. Okay. Does anybody remember the ratio for cosecant? It is hypotenuse over opposite, or I can think about it as the reciprocal of sine. That's probably the easier way to think about it. So I know what sine is equal to. Cosecant is its reciprocal. So I can just write it as the square root of 29 over 5. Since I knew what sine was, I can find cosecant really easily. Everybody okay with that? Notice that there's no square root in my denominator, so there's no need to rationalize my denominator. That answer is fine just the way it is. Similarly, secant is going to be the reciprocal of cosine. And likewise, cotangent is the reciprocal of tangent. 2/5. Cotangent? Okay. That's okay. That's okay. Any questions about this kind of a problem? So in order to do this, all that you really need to know is SOHCAHTOA, and then which ones are the reciprocals of sine, cosine, and tangent, right? If you know that, you've got it all. Everybody agree? Okay. Again, you had to remember the Pythagorean Theorem, I guess, as well. But let's do another example. So, in this problem, we're said that theta is an acute angle of a right triangle. We're told sine theta is 1/3, and we're asked to find the values of the other 5 ratios. What do you suppose should be the first thing we do to answer a problem like this? Yeah, let's draw a picture. The picture that we should draw in this case should be of a right triangle. So there's my right triangle. And I should label one of the 2 acute angles as theta. Does it matter which one I pick? No. I'm going to just pick this one in the lower right-hand corner. And just for the sake of us communicating with each other, I'm going to label the vertices of this triangle as A, B, and C. So in order to find the other 5 ratios, I need to know the side lengths of this triangle. So right now I have enough information to label 2 of them immediately. How do I have that information? I know that sine theta is 1/3, and I know that sine is opposite over hypotenuse. So I know the opposite side should have length 1, and the hypotenuse should have length 3. Which side should I label as 1? AC, AB, or CB? CB. Which side should I label as 3? AB or AC? AC. How will I find side AB? The Pythagorean Theorem. So when I plug in my values to the Pythagorean Theorem, which value should I plug in for side or for A? 1. What should I plug in for B? B is what I'm going to be solving for. And what should I plug in for C then? 3. So if I solve that then, I get that B is equal to the square root of 8. Or if you remember, we can simplify this. How does the square root of 8 simplify? Do you remember this from your algebra course last year? So I can think about it as the square root of 2 times the square root of 4. And the square root of 4 is just 2. 9 minus 1. That's okay. Does everybody kind of remember that from last year? Okay. So I'm going to write that as 2 square root 2. And now we have everything we need to write the other 5 ratios. And I guess I could write that we know sine is 1/3 already. Okay. Who can tell me what the ratio for cosine is? Adjacent over hypotenuse. So in this case specifically, it's going to be 2 square root 2 over 3. Is that okay with you guys? Okay. How about for tangent? One over 2 square root 2. Now, do I like the way that's written? No. What should I do to that problem in order to get it into a form that we like? Multiply the top and bottom by the square root of 2. So 1 times the square root of 2 is just the square root of 2. The square root of 2 times the square root of 2 is 2, but I also have this extra times 2 out front, so it's really 4. Everybody okay there? Cosecant is the reciprocal of which one? Sine. So the reciprocal of 1/3 is 3. Secant is the reciprocal of which one? Cosine. So I can write secant is 3 over 2 square root 2. But I'll need to rationalize that denominator just like we did before. Good. 3 square root 2 over 4. That's correct. And then cotangent is the reciprocal of tangent. So the reciprocal of 1 over this 2 square root of 2 is just 2 square root 2. Everybody feel okay here? Okay. What if I ask you to find the sine of 30 degrees without using your calculator? At first glance, you're probably thinking there's not enough information to do this problem. I assure you there is. So there's a catch, though, is you have to remember something from your geometry course. So you have to remember the 30, 60, 90 triangle. Hopefully at least you remember that verbiage, that was a thing in geometry. What was special about the 30, 60, 90 triangle is that its side lengths existed in a set ratios. So the side opposite the 30 degrees is x. The side adjacent to the 30 degrees is x square root 3. And the hypotenuse is 2x. So if I remember this, if I want to now calculate sine of 60, or I'm sorry, sine of 30, Sine of 30 is opposite over hypotenuse, which just simplifies down to 1/2. Lexi? So the x is reduced, right? And what happens to things when I cross them off? What do they turn into? Ones. So I have 1 over 2 times 1. Okay? Everybody okay with that? So if we ask you to find the sine, cosine, tangent of a 30 or 60 degree angle without a calculator, you can do that by using that special right triangle, just like we did in the example. Was there another kind of special triangle that you remember from your geometry course? There was the 45, 45, 90 triangle. And again, the side lengths of the 45, 45, 90 triangle exist in special ratios. Oops. I do not. Do you need to go get one? Sure. So these two triangles, the 30, 60, 90 and the 45, 45, 90 triangle, will be really important to us kind of going forward. These are both things that you'd want to kind of commit to memory as they become really kind of useful in our future. So, for example, if I wanted to find sine of 45, that would be x over x square root 2, which reduces to 1 over the square root of 2. And when we rationalize the denominator, we'd have square root 2 over 2. So let's say we want to find sine of 17. Is 17 a special angle? Is it 30, 45, or 60 degrees? How would we go about doing this then if we can't use one of our special triangles? Hannah? Subtract what from 90? 17? So that's 163. Then what? Okay, so that's 73. Sophia? Yeah, we'll use our calculator. So everybody take out their graphing calculator. Locate the sine button on your graphing calculator and type in sine of 17. How many of you are getting a number that's different than mine? Probably most of you, right? How many of you are getting a negative number? Does that negative number make any sense at all? No, right? What kind of number should we be getting? Should be positive, right, if it's the ratio of two side lengths. So what's going on? Your calculator is in the wrong mode. So locate the mode button, which is right next to the blue second button. Notice the third option is between degrees and radians. What mode should our calculator be in if we want to find sine of 17? Degrees. So let's go ahead and change that. So move your cursor to where it says degrees and press enter to change it into degree mode. Once you've done that, exit back out and try sine of 17 again and make sure that you get the same value that I have here. This 0.29 yada yada yada. Okay? This is a very important skill that you should be able to do over and over and over again, because in this course we'll do things in both degrees and in radians. You will have to make sure that you're changing the mode of your calculator back and forth between degree mode and radian mode, because I promise you there will be a situation that every single one of us will probably do, best case scenario, an entire homework assignment wrong because we're in the wrong mode. Worst case scenario, do an entire quiz or test wrong because you're in the wrong mode. So please make sure that you're conscious of the mode that your calculator's in. Look at the question. Ask yourself, is this angle in degrees or radians? And make sure that you change your calculator mode appropriately. In addition, I would say that be conscious of the number that the calculator is giving you. If you get a number that doesn't make any sense, like it's giving you a negative number when you expect a positive number, the number one case if you're getting numbers that don't make any sense is your calculator's in the wrong mode. So first thing you should check if you're getting a number that doesn't make any sense to you is to make sure your calculator's in the correct mode. Everybody feel comfortable about changing the mode on their calculator between degrees and radians? Okay. What if I wanted to, say, find secant of 78 degrees? Is there a secant button on our calculator? I don't see one, right? So how am I going to type in secant onto my calculator? I'm going to use the reciprocal of cosine, exactly right. So I'm just going to do 1 over cosine of 78, which gives me 4.8 yada yada yada. Alternatively, I could have done cosine of 78 and then press this x to the negative 1 button here that's 4 down from the second, and that'll do the same thing. So this negative 1 exponent, we remember from our algebra course last year, is the same thing as a reciprocal. So you could use that instead of typing 1 over cosine of 78. Do you need to go get a drink of water? Oh, you have one. Sorry. You're welcome. It sounded like you were struggling there a little bit. All right. Last example for this section. So let's say that we're asked, our directions say solve the triangle. What do we mean by solve the triangle? What is that direction asking us to do? So it's asking us to find all the missing angles and all the missing sides. When you say solve the triangle, we want to find all the rest of the information about that triangle. Is everybody okay with that direction? So which of these is going to be the easiest thing to find first? The angle C. Very good. How do I find angle C? Okay. Or you could just do 90 minus 41. Same thing. So what Lexi used there was called the triangle Sum Theorem, that says that the interior angles of our triangle add up to be 180 degrees. So that's where the 180 comes from. Or you can use the corollary to the triangle Sum Theorem that says in a right triangle, the two acute angles add up to be 90 degrees. Either one is fine. Doesn't really matter how you get that C is 49, just that you need to get that C was 49. Everybody happy with that? Okay. So to find the side lengths, CB and AC, what we're going to use are our trig ratios. So I'm going to start by picking an angle that I'm going to use. Doesn't matter which angle we pick, but we need to pick one. I'm going to pick the 41. And now I'm going to pick a side to solve for. Doesn't matter which side I pick to solve for first. I'm going to pick side CB. I'm going to label that side X. And then I'm going to use the side that I know about. So relative to that 41 degrees, side X is opposite, adjacent, or hypotenuse. This is the opposite. And relative to that 41 degree, 12, the side that I know, is that opposite, adjacent, or hypotenuse. Adjacent. So which trig function should I use if I'm concerned about opposite and adjacent? Tangent. So I'm going to write that tan of 41 equals opposite over adjacent. And now I'm going to solve for x. What do I need to do to solve for x? Multiply both sides by 12. And then I'm going to type that into my calculator. And I get approximately 10.431. I don't know how many decimal places. Let's round to 3, I guess. Are we okay with what I've done to get that? So again, typing it into my calculator, I typed it in like exactly as it looked on my sheet of paper. I just did 12 times tan of 41. Everybody's okay with that? Okay. Now let's say we want to solve for the other side. For the sake of argument, I'm going to call that other side y, just to give it a name. How can we solve for this other side y? So we could use, the best method to use is to do the same process we just did. So we're going to pick an angle. Let's say that the angle that we're going to use again is this given angle, the 41 degree angle. This time we're concerned about finding side y, and the side we know is this side 12. So relative to that 41 degree angle, 12 is still adjacent, but the y is the hypotenuse. So the trig function I want to use if I'm concerned with adjacent and hypotenuse is cosine. So I know that cosine is adjacent over hypotenuse. So I can say cosine of 41 equals 12 over y. Now what I want to do is solve for y. What should be the first step to solve for y? I'm going to multiply both sides by y to get rid of the fraction. So that's going to give me y times cosine 41 equals 12. And then to get the y by itself, I'll divide both sides by cosine 41. To give me y is 12 over cosine 41. And then I'll just type this into my calculator. And I get 15.900 approximately. Okay with that? Let me point out for you guys a nice check that we have to make sure that we've done this correctly. What is a couple ways that we could check to make sure we've solved this triangle correctly? Good. We could make sure that the Pythagorean theorem still holds. So let's do that on our calculator. So we should have that this 10.431 squared plus 12 squared. That number should be about the same thing as this 15.900 squared. Is that close enough? Okay, let's come back to that in just 1 second. So that's close enough. Why are they Why are they slightly different? Though, shouldn't they be exactly the same? Why are these slightly different? Because we had to round our answers, right? Instead of using the full decimal for 10.431 and all the decimal after it, and the same thing with the 15.900 and all the decimal after that, if we had used the full decimal, we would get them to be exactly the same. But we rounded, so they're going to be a little bit different, which is all we're seeing here. So I would be, at this point, convinced that I had done this problem correctly. There's a second check that's even faster that doesn't require us to use our calculator. That second check is that the biggest side should be opposite the biggest angle. The middle side should be opposite the middle angle. and the smallest side should be opposite the smallest angle. So let's go back and look at our information here. So our biggest angle is the 90 degrees. And I notice that that is opposite the longest side. The middle angle is 49. That's opposite the middle side. And the shortest side is opposite the shortest angle. So again, I'm pretty convinced that I've done this problem correctly. Is everybody okay with how I can use that as a check? And that's a nice check because it's really fast, right? Specifically, what this is going to help you catch is if you use the wrong mode on your calculator to do these problems. So if you did use the wrong mode, these checks will help you catch that. Now, Matt had an interesting question here just a moment ago, talking about finding y. He asked, could I use the Pythagorean theorem to find y? And my answer to you, Matt, is it depends on how accurate you need to be. Using the Pythagorean theorem to find y is going to be less accurate than what we just did, because to use the Pythagorean theorem, we're using a rounded answer and then having to round again at the end. So it's going to be slightly less accurate than what we had done previously. So we had 15.900155592 is like the best version. If we had used the Pythagorean theorem, let's just illustrate to you what we would get, just so everybody can see. Oops. Oh my goodness. Oh my goodness. Oh my goodness. So this is me using the Pythagorean theorem. And you'll notice I get something slightly different. Now, depending on where you're doing the rounding at, probably doesn't matter. If you're trying to land a rocket on the moon, probably does matter. For the most part, Matt, with the way we're asking you to do the rounding, I don't think it'll make a difference, although it could. So those of you thinking about doing engineering, this is a real-life engineering kind of question, like which answer should we be using to get our next answer, and like how many decimal places should I take with it, and all these sorts of things are really kind of practical kinds of questions. For this course, in this context, I don't think it'll make much of a difference. But that's a good question to ask, Matt. So let's stop here.